In this DVD, I will cover the 13 standard tests that ship with particle flow. Tests are used within particle flow as decision points within a flow where particles can be tested for a certain value or condition, and then kept in the event if they fail it, or be passed out through the test wire to a new event if they meet its criteria. Tests are used to enable a great deal of functionality, so it's very important that you have a thorough understanding of them to make the most out of particle flow. So, let's start by having a look at the age test. The age test is a key operator in that it allows you to change your particles based on their age. This is one of the most common actions when working with a particle flow. For instance, you may want to make your particles explode when they reach a certain age, or for a seed to grow into a flower, or maybe be removed from the simulation with the delete operator. This is where the age test comes in. Let's have a look at the GUI and the options that it offers. The first item is the type flyout, which you can see here. With this flyout you can choose exactly what kind of age that you're testing about. Remember that in all cases age is based on frames, and that frame count changes between animation systems. For instance, PAL, you have 25 frames per second, and in NTSC you have 30, and in film you have 24. This means that if you set your age test to 30 frames in NTSC, then you switch to PAL, particle flow will automatically change your test value to 25 to keep the same relative timings in place. This is because, as I just said, in NTSC 30 frames is 1 second, whereas in PAL 25 frames is 1 second. So if you switch from NTSC to PAL, particle flow will automatically convert the time values to actually give you exactly the same timing in terms of seconds. There are 3 age type options you can choose from, and they are absolute age, which you can see here, and this tests the value that you set against the actual simulation frame number. This is useful if you want to base the test on a particular frame rather than the actual age of the particle itself. Particle age is generally the most useful option, as the test is actually based on the age of the particle itself. And you can see that here. This is the second option. And as I said, that's actually based on the age of the particle, so it's very specific to each particle. The third option is event age. And in this case, the age of the particle is based on the amount of time in frames that it's actually been in the event in which the age test is taking place. This is useful for checking how long a particle has been in a particle event and then acting upon it. The next option we have is the test true if particle value radio box. As you can see, you have 2 choices, and they're very simple. Is the particle less than the test value, or is the particle greater than the test value? In other words, is it younger than the test value, in which case the test is true, or is it older than the test value, in which case at that point the test becomes true. So we go on to the next 2 values here, which are the test value. This is obviously the value itself that you're testing for. So if we use particle age, and we use a test value of 15, and it's greater than, we look at the actual age of the individual particle, and if it's greater than 15, we treat our particle as passing the test, and it gets sent out through the wire to the next event. So you can actually see we have this age test here, which is set to 20. You can see it's based on particle age. When it is greater than 20, it's sent out to the next event. And you can see in this age test here, which is the original age test we were looking at, you can see that when the test value is 15, with a variation of 10, it gets sent on to the next event. So in this age test we have a variation of 10. That value is added and taken away from our test value to give us a range of from 5 to 25. So our particle could be anywhere from age 5 to 25. This is determined obviously randomly for each particle. When that condition is met, it's sent on to the next event. The next option we have, which is common to a lot of operators and tests, is subframe sampling. In other words, have the particles been birthed between frames rather than on the actual frames themselves. If this is the case, and you require that extra accuracy, then turn on subframe sampling. Subframe sampling does actually slow down the calculation slightly, so if your particular flow doesn't actually suffer from the puffing effect that you can actually see when you have subframe sampling turned off, then don't use this option, because it'll just slow down your flow slightly. And finally we have the seed. And this is very similar to a lot of other operators that we've looked at in this series, and it's just a random seed which will get applied to the random values generated here. So let's very quickly run through what this actual example does here, and then we'll go on to the next test. So